In this video, we're going to be taking a look at scatter diagrams and linear correlation. A scatter diagram is something that you have likely made before in your mathematical career, but you might not have used that terminology. So first we'll start by defining what a scatter diagram is. A scatter diagram, which is sometimes also called a scatter plot. So a scatter diagram or scatter plot is a graph in which data pairs in XY format are plotted as individual points on a grid with X on the horizontal axis and Y on the vertical axis. So basically, it's just a standard graph, a standard XY, rectangular coordinate graph. But in a statistical context, we tend to refer to those as scatter diagrams or scatter plots. And one other change in terminology from what you've likely dealt with in maybe previous algebra courses is rather than calling X the independent variable and Y the dependent variable, since the terms independent and dependent have different meanings in a statistical context than they do in an algebraic context to a certain extent, what we refer to them as is we call X the explanatory variable. So X is the explanatory variable and Y is the response variable. Okay, so another little change in terminology from what you've likely dealt with before. Now, making scatter diagrams is very, very straightforward. You can certainly make them by hand, but it's just as easy if you're trying to get a picture of what's going on in your graph or with your data to make them in the calculator. So I'll tell you about how to do that. Let me grab some data here. Oh, let's see. So here's some data looking at the X is the average number of employees that are in a group health insurance plan, and Y is the average administrative cost of the plan as a percentage of the claims. So we're looking at some health insurance data. And so we have X and Y, and these data are given in table format. The X values are 3, 7, 15, 35, and 75. And then the Y values are 40, 35, 30, 25, and 18. Okay, so those are our data points. Now let's say we wanted to create a scatter diagram for these data. So that's our goal. We want to create a scatter diagram for the above data. And again, you could certainly do this by hand. It would be pretty straightforward. These, values would go on the x-axis. These values would go on the y. But I will show you how to do that in the calculator, because in the calculator it's also very straightforward. So if here's your calculator, you want to press Stat, Oops, sorry. First you want to make sure your calculator is turned on. Then you want to press Stat, and we want to go into Edit, and then we'll be putting our X data into one list. I'm just going to use list 1, and our Y data into another list. Let's say list 2. So my X data was 3, 7, 15, 35, and 75. And my Y data was 40, 35, 30, 25, and 18. Okay, so there's our data there. Now to get my calculator to graph this XY data, I would go to second Y equals. That's going to take me to my stat plot menu, and we've been here before. This is the place where all of our different statistical data displays live. I'm going to select the first plot by pressing Enter. Make sure that the word on is highlighted here. If off is highlighted, you'll want to press Enter to highlight on. And then this very first icon here in the screen, that's your scatter diagram icon. So you'll want to press Enter to select that. The calculator will ask you for the X list, which list are the X data points stored in, and I had them stored in list 1. And then Y list, which list had the Y data. Mine was in list 2. If your data are somewhere else, you'll want to change those. And then for mark, you get to pick the kind of mark that the calculator uses, either the square, the plus, or the dot. I would recommend either the square or the plus. That little dot is very tiny and it can be really difficult to see on the screen. And then to get the calculator to pick an appropriate window, we'll press Zoom, and then we want option 9. So you can either scroll down to option 9, which is your zoom stat, or you can just press the number 9. And that's your statistical zoom, and it will find the data and zoom in on it. And here we can see we have a graph of the data. And then once we have that graph, we can simply transfer the image that we were seeing, essentially a brief sketch of it, onto our paper. And here this was our X, this was our Y. We had from the calculator something that looked sort of like this. And then there's one other thing that you really want to do here. You do want to label your X and Y axes with what the variables were referring to. What was your X variable, what was your Y variable. And then in addition to that, you also want to give some indication of scale here. What is X going from and to, and what is Y going from and to? So first let's go ahead and label them. X, again, was the number of individuals in the healthcare plan. So number of individuals in healthcare plan. And Y was the percent administrative cost. Admin cost as percent of claims. Okay, so we've got those labeled, so that's good. Then, because we let the calculator pick the window, you can't really see here what window was used, and you don't have a good indicator. So certainly you could just use these values. You know that this first data point starts at 3, this last data point goes up to 75, so you could just put a min and a max there. Same thing with, 18 is the lowest one here, 40 is the highest one there. But also if you want to see the exact window that your calculator used, you can press the window key, and that'll give you an indication of where your values were going from and to on that window. So you can do either one. I'm actually just going to go ahead and use these markers. So here, this first data point's X value was at 3. Then up here, this one was at 75. Then here, this first value was at 18. That was our lowest Y value. And the highest Y value here was at 40. And then also here we should put a break on this axis, because it does appear that that starts just right above 0, and really we've cut off, or we've squashed a little bit of the axis there. So if you've squashed part of the axis, you'll want to put a break in there. That won't always be necessary, but here we probably want to do that. And so there is our scatter diagram. And one of the things that we're interested in doing when we create a scatter diagram is we want to determine, is there a relationship between the two variables? Does it look like there's a relationship between X and Y? And what is the nature of that relationship? Now, in this particular set of data, we kind of have an interesting set here. Normally, for the purposes of this class, our intro stats class, we'll be looking at data sets that are pretty linear. They'll form an approximate straight line. This data set actually looks curved to me. It doesn't look particularly linear. But again, your book is only going to focus on fitting straight line relationships to data, and this particular data set doesn't look like it has a straight line. So in the next video, we'll take a look at linear correlation and how we determine a numeric quantifier for how related these two variables are.